If the weather section is wrecking your practice scores, here's the good news. It is not 50 facts to memorize. It's one idea wearing a bunch of different hats. Inversions, cloud types, turbulence, fog, icing, wind shear. People try to memorize each of those separately, and they drown. But underneath every one of them is a single question. Is the air stable or unstable? Learn to answer that one question, and the whole section falls into place. In the next 20 minutes, I'll give you that one mental model and then show it solving every kind of weather question the exam can throw at you. Let's make weather the easy part. Here's the whole weather section in one sentence. Stable air is smooth and layered. Unstable air is building and bumpy. That's it. Stable air resists rising, so moisture spreads out sideways. You get flat stratus clouds, a smooth ride, and hazy, low visibility because everything's trapped near the ground. Unstable air keeps rising. It stacks up into puffy cumulus clouds, gives you turbulence and showers, but good visibility because it mixes the haze away. Don't read one clue. Read the set. So let's turn that switch into something you can actually read off a weather report or out your window. Stable air gives you a set of clues that all point the same way. Flat, layered stratus clouds. A smooth, steady ride. Hazy, poor visibility because the haze is trapped down low. And if it precipitates at all, it's steady drizzle, not showers. Unstable air flips every one of those. Puffy, piled up cumulus clouds. A bumpy, turbulent ride. Good visibility because the air keeps mixing. And showery precipitation that comes and goes. Here's the discipline that scores points. Don't grab one word and answer. Read the whole set. If a question hands you stratiform clouds, smooth air, and steady precipitation, every clue is pointing at stable, so the answer is stable air. A temperature inversion is stability turned up to maximum. Normally, air gets colder as you climb. In an inversion, it gets warmer with height, a warm lid that nothing can rise through. That lid traps smoke, haze, and fog underneath it. Smooth air, but terrible visibility. And memorize this number: when the wind 2,000 to 4,000 feet above the surface is at least 25 knots. Expect wind shear right at the top of that inversion, because calm air below is sitting under fast air above. Just remember 25 knots. Lifting air doesn't decide what cloud you get. The stability of the air does. Take warm, moist, stable air and shove it up a mountain slope. Because it's stable, it flattens into stratus clouds or upslope fog. Now take unstable air and give it the exact same push, and it explodes upward into towering cumulus and thunderstorms. Same lift, opposite result. The air was the difference. So when a question describes air being forced upward, don't answer from the lifting. Answer from whether the air is stable or unstable. Fog is just our stability idea meeting moisture at the surface, and it comes two ways. Advection fog needs movement. Warm, moist air sliding horizontally over a cooler surface with a little wind to keep it going. Think sea air drifting inland on a winter morning. Radiation fog is the opposite. No movement at all. A clear, calm, cool night where the ground radiates its heat away and chills the air just above it. Here's the tell. Wind and clouds kill radiation fog, but wind is what feeds advection fog. So if the question mentions moving air over a cooler surface, it's advection. If it's a clear, calm, cool night, it's radiation. Two processes add moisture to the air: evaporation, liquid water turning to vapor, and sublimation, ice turning straight to vapor. Anything that pulls water back out, like condensation or precipitation, is the wrong direction. So when a question asks how moisture gets added to air, It's evaporation and sublimation. And here's how you see it coming. When the temperature and the dew point squeeze together, and that spread is small and shrinking, the air is near saturation, and fog, or low clouds, are on the way. Now the violent end of instability, thunderstorms. 3 quick facts the exam loves. 1. The defining feature of a thunderstorm is always lightning. Not hail, not heavy rain. Those come and go, but thunder means electrical activity, so lightning is always there. When a question says always, pick the defining feature. 2. The most turbulent cloud in the sky is the cumulonimbus, the thunderstorm cloud itself. Violent up and down drafts, the most dangerous air there is. 3. A thunderstorm grows through 3 stages: cumulus, mature, and dissipating. And the mature stage is the most hazardous, when the updrafts and downdrafts are both raging at once. Icing is the same instability story, just below freezing. The question the exam asks is, which situation builds ice the fastest? The answer is freezing rain. Its drops are large and supercooled. They hit the aircraft, spread out over a big area, and freeze, piling on ice faster than anything else. Rank it. Freezing rain builds ice the fastest, then freezing drizzle with its smaller drops, and cloud droplets are the slowest. So if you see highest accumulation rate, the answer is freezing rain. Big drops, big ice. One more, and it ties right back to shear. The wind at the surface is not the wind a couple thousand feet up. Down near the ground, friction drags on the moving air. So the surface wind is slower than the wind aloft, and it's also shifted, backed a little to the left of the wind above it. That's why a reading on the ground is lighter and pointing a bit differently than the winds aloft forecast. And it's the exact same idea as inversion shear. Whenever a slow layer sits under a fast layer, the sharp change across that boundary is where the shear lives. Let's read it on paper, because the exam makes you. On a METAR, find the 2 numbers separated by a slash, near the end. That's temperature over dew point, in Celsius. The gap between them, the spread, is your stability and moisture tell. When temperature and dew point are close together and squeezing closer, the air is near saturation, and fog or low clouds are likely. A wide spread means dry air and clear skies. You're not memorizing the whole code, you're hunting for that one thing, the temperature dew point spread. A TAF is just the forecast version, and a few codes tell you the stability story directly. SHRA means showers, showery, so unstable air. TS means thunderstorm, lightning, the violent end of unstable. And BR or FG, mist or fog, means the air has saturated near the ground. Low visibility, the stable, moist end. Spot those 3 codes, and you already know what kind of air is coming before you decode another thing. Here's the whole section on one card. Stable air is smooth and layered. Stratus clouds, a steady ride. Poor visibility, steady drizzle. Unstable air is building and bumpy. Cumulus clouds, turbulence, good visibility, showers. An inversion is stability maxed out, a warm lid that traps haze and fog. And expect wind shear on top of it when the wind 2,000 to 4,000 feet up is 25 knots or more. Lift doesn't pick the cloud, the air's stability does. Advection fog moves in on the wind over cool ground. Radiation fog forms on a clear, calm, cool night. Moisture is added by evaporation and sublimation. Thunderstorms always have lightning. Cumulonimbus is the most turbulent cloud, and the mature stage is the worst. Freezing rain builds ice the fastest. One line runs through all of it. Stable is smooth and layered. Unstable is building and bumpy. Now go make it automatic. There's a free weak spot drill on Droneworthy, built from the exact weather questions that trip people up. Stability, inversions, fog, icing, and it explains every answer the moment you tap. Pair it with the free sectional reader for the airspace side, and the full practice set that tells you why every wrong answer is wrong at droneworthy.com. Stop memorizing 50 facts. Learn the one idea and start reading the sky.